In this lesson, our objectives are to be able to use the segment addition postulate and angle addition postulate to solve problems. Segment addition postulate. This says point B is between points A and C if and only if AB plus BC equals AC. Remember that if and only if means that this statement works both ways. Let's take a look at a picture to illustrate the segment addition postulate. On a line, let's put points A and C and B somewhere between them. Notice I didn't show it exactly in the middle because that's not what between means. Between doesn't mean it has to be right in the middle. What between means is that AB, this little segment right here, AB, plus BC, this segment next to it, altogether must equal AC, all the way from here to here. And if it's true that AB plus BC equals AC, then point B is between points A and C. Let's assign some values to it for it to maybe make a little bit more sense. Let's pretend that AB is 3 units long. AB equals 3. And BC is 5 units long. Notice when I mark how long a segment is, I put it right in the middle, over top or underneath of the segment. That means that all the way from A to C is 3 plus 5, or 8 units long. If AB is 3 and BC is 5, then AC is 3 plus 5, or 8 units long. That's the segment addition postulate. A midpoint is a point that divides a segment into two congruent segments. Let's take a segment and show a midpoint. I'm going to call this M for midpoint. To show that it's the midpoint, I mark each of these segments with congruent marks, hash marks that are of the same style to show that they are both congruent to each other. Bisect means divide into two congruent parts, just like the midpoint. Let's draw a picture and we can discuss this segment using this verb bisect. We'll call this segment ST and label M as the midpoint. We'll show that it's the midpoint by showing congruent marks for this segment and this segment. We're using different style hash marks because we don't want our readers to think that this segment is congruent to this segment. These segments are congruent to each other, but not necessarily to these segments. We can say here that M bisects, that's the verb to cut in half, segment ST. Segment bisector, that is a point, array, line segment, or plane that intersects the segment at its midpoint. If we go back up to this picture here, M is the segment bisector of segment ST. Let's write a note about that using this new vocabulary. M is a segment bisector of segment ST. Saying bisects is the verb, being a segment bisector is what it is, the noun. Let's take a look at this example. Point M bisects segment VW. Before I keep reading, I want to illustrate in my picture what that looks like. If M is bisecting segment VW, that means this half and this half are congruent. Notice I'm using a new style hash mark as to not get it confused with the other pictures. VM equals 4x minus 1. Without the hat, that means the length. So this is indicating the length of segment VM. Let's show that in the picture by writing 4x minus 1 where this segment is. And MW equals 3x plus 3. Here's MW. Let's write 3x plus 3 in the middle of that segment. Find the lengths of segment VM, segment MW, and segment VW. So using the segment addition postulate, I know that this segment plus this segment equals this entire long segment. However, because it says M bisects this long segment, I know that these two halves are congruent. Therefore, I'm going to write that 4x minus 1 equals 3x plus 3. And I need to solve this equation for x. Let's get our x's together, minus 3x to both sides, so that we get x minus 1 equals 3. Let's move stuff away from the x, plus 1 to both sides, and now we have x equals 4. Notice it didn't say find the value of x. It said find the lengths of these segments. Now that I know what x equals, I can do that. Let's start with segment VM. In the directions, they told us that VM is 4x minus 1. In place of x, I will substitute the value 4. 4 times 4 is 16, minus 1 is 15. Next, I'm going to find MW. Well, they do tell me MW is 3x plus 3, but remember that we know these two segments are congruent. So if I know that this segment is 15, now I know that this segment is also 15. So I don't have to do substituting again, I just know that these are the same length. Finally, VW is all the way across from V to W, which is adding the 15 and the 15 together. So adding 15 plus 15 makes 30. Thanks for watching.